Internet Gateway versus NAT Gateway. Understanding AWS Network Architecture. Master the crucial difference between these two AWS gateways and when to use each. When building secure, scalable applications on AWS, understanding how your resources connect to the Internet is fundamental. Two key components handle this connectivity: Internet gateways and NAT gateways. While they might seem similar, they serve completely different purposes and security models. The Internet Gateway. An Internet gateway creates a direct, bidirectional connection between your public subnet and the Internet. Think of it as the front door of your VPC, wide open for anyone to knock. How it works? Your Internet gateway sits at the edge of your VPC, connecting directly to AWS's Internet backbone. When you place an EC2 instance in a public subnet with an Internet gateway route, that instance gets a public IP address and can both send traffic to the Internet and receive traffic from anywhere on the web. Perfect use cases: web servers that need to serve content to users worldwide, load balancers distributing traffic across your application, bastion hosts providing secure access points to your private infrastructure, public APIs that external systems need to reach directly. The architecture is straightforward: Internet, Internet gateway, router, public subnet, your EC2 instance. Every component in this path can be reached from the outside world, which is exactly what you want for public-facing services. The NAT gateway, a one-way security shield. A NAT gateway provides a completely different model: outbound Internet access without inbound exposure. It acts like a security guard that lets your private resources reach out to the Internet while blocking all incoming traffic from external sources. How it works? The NAT gateway sits in your public subnet, but serves your private subnet. When a private instance needs to download updates, access APIs, or send data to external systems, the request goes through the NAT gateway. The gateway masks the private instance IP address and forwards the request using its own public IP. Here's the crucial part: responses can come back because the NAT gateway maintains the connection state, but new inbound connections from the Internet are completely blocked. Perfect use cases: application servers that need to download software updates or patches, database servers requiring access to external APIs for data enrichment, back-end services that process data and send results to third-party systems, worker nodes that need to pull container images or access cloud services. The flow looks like private instance, NAT gateway, Internet gateway, Internet. Notice how the private instance never directly touches the Internet gateway. The security architecture difference. Both setups use the same security layers, NACLs, and security groups, but they apply them differently. With Internet gateway, security groups act as your primary firewall, controlling exactly which ports and protocols can reach your public instances. NACLs provide subnet-level filtering as an additional security layer. You must explicitly configure what traffic is allowed in and out. With NAT gateway, private instances are inherently protected from inbound Internet traffic. Security groups still control outbound access from private instances. The NAT gateway itself handles the Internet-facing security concerns. Choosing the right architecture. The decision comes down to one fundamental question: does the Internet need to initiate connections to your resource? Choose Internet gateway when users need direct access to your service, external systems must connect to your application, you're building public-facing infrastructure, you want the simplest possible network path. Choose NAT gateway when your resources only need outbound Internet access, security requires blocking all inbound Internet traffic, you're running internal services that occasionally need external data, you want defense-in-depth network security. Real-world implementation. Most production AWS architectures use both gateways together. Public subnets with Internet gateways host your load balancers, web servers, and NAT gateways. Private subnets with NAT gateway routes host your application servers, databases, and internal services. This hybrid approach maximizes both functionality and security. Your public-facing components get direct Internet access for performance, while your sensitive back-end systems remain completely isolated from inbound Internet traffic. The bottom line: Internet gateways and NAT gateways aren't competing solutions. They're complementary tools for different network requirements. Master both concepts, and you'll be able to design AWS architectures that are both accessible to your users and secure from external threats. Understanding these networking fundamentals is essential for any cloud architect or developer working with AWS. The visual diagram shows exactly how traffic flows through each component, making it easier to troubleshoot connectivity issues and design robust, secure cloud infrastructure.